3-1. We're doing lines and angles. I don't know if this class was one of the classes that asked about this in the last chapter, but we talked a little bit about parallel lines at one point in time and how you can't just say parallel lines are lines that don't intersect. Was that in this class? Does that sound familiar?
Yes.
Can anyone tell me what parallel lines are?
I got you.
Let's hear it.
Okay, they don't intersect.
They're like
But
this.
They don't
also-
intersect.
They're like this.
Yeah, okay.
Mm-hmm.
Yeah, they're next to each other.
Next to each other, yes. The key thing that you need to know when defining parallel lines is this word right here.
Never.
They are coplanar, okay? So parallel lines have to be coplanar lines that don't intersect. What is coplanar? On the same plane, okay? Coplanar lines that don't intersect. So I'm going to draw you a picture, and we're going to kind of refer to that picture with what we know of these things. Before I do that, just know that when you see this from me, when they draw two parallel lines, you need to think of that as is parallel to. Okay? But here's the picture we're going to work from right now. So we're just going to draw a cube. Go ahead and draw yourself a cube. However works best for you. I draw mine like that. So if this is A, B, C, D, and E, F, G, and H. Okay? In this picture, there are lots of sets of parallel lines. Anyone think they can tell me one pair of parallel lines? DJ.
DH and BF.
DH and B.
Oh, no. DH and CG.
Okay, what did you say? BF for the other one? Those are parallel too.
Okay.
It's just not on one of the planes that you see, but there is a plane that would go through that, so that would be okay. So we would say DH, line DH, is parallel to, right? You put your little parallel lines in there. Line CG. Now, here's the deal with this. There is a way that we mark lines parallel. And it's kind of like how we mark lines congruent or segments congruent or angles congruent. But now we do it with arrows instead. So DH and CG marked parallel would just put an arrow on each one of those. Can someone give me a different pair of parallel lines that are not parallel to those two?
I got you.
Well, you gave me the last one. Let's let someone else try.
Can I try?
Sure, John, try.
AD and
Stop it. Not you.
AD and CB.
AD.
Good job, bro.
Okay, AD is parallel to BC, CB, either way. So here's the deal. We already have the two vertical lines that are marked parallel. So if I want to mark these ones parallel, they're not parallel to the first set. So instead of just a single arrow on each one, you would do a double arrow like this. Okay, so just be clear when you're marking which ones are parallel or when you're looking at which ones are parallel that you mark them appropriately. Okay? Okay, so that's parallel lines. Skew lines. Skew lines are the reason we can't define parallel lines as lines that never intersect, because skew lines don't intersect either. The difference is skew lines are non-coplanar. Lines that don't intersect. Okay, non-coplanar being the key word there. They cannot lie in the same plane. Anyone think they can give me a pair of skew lines based on that definition? They don't lie in the same plane, but they don't intersect. Yes, like this. But where? Give me two lines in the picture that do that.
So it's like there's a square and then
Okay, bro.
there's one is a square.
You smart.
There could be if there were points labeled as that. Can you give me like a for instance from this picture?
AB and HG.
Those would actually be parallel, because I could draw a plane through both of those, but you're on the right track.
A, B, and E, F. Nope. A, B, and A, E. I'm
A, B, and A, E intersect. They can't intersect, right? Ian. A, E, and F, G. There it is. So we could say A, E, and F, G are skew. Okay, so here's AE, here is FG, not in the same plane, but they're never gonna touch, right? If you think of a Kleenex box, if I pick like this line here, and then this one going this way here, those will never touch, right? It's a line here and a line here. They're not parallel, they're going different directions, okay? But there's no way they're ever gonna meet, okay? That's skew. Good on that? Wanna give me one more set of skew lines?
Yeah, I can do that.
I feel you both have given me one. I want someone who hasn't given me. Sure, Grace.
A, B,
A, B, and
and DH.
DH, right. Oh, you made a cross. A, B, and DH are skew. Notice it looks like they intersect in our picture, but that's because our picture is two-dimensional and we're dealing with a three-dimensional figure. DH is behind, AB is out in front, okay? So that's skew. Can you tell me from that picture a pair of parallel planes?
No.
How many letters do you need to name a plane?
3.
At least 3. You could use more, right? You can use as many as you want, but you need at least 3. So in this picture, that same cube, can you tell me 2 parallel planes? In other words, planes that are never going to intersect. Now, parallel planes won't be in the same plane, right? Because they're 2 different planes.
Oh, plane.
So 2 planes that are parallel. Anyone give me a pair? Isabel.
ADH and FGC.
Yes, so plane ADH, right? That would be the left side of our picture. And then plane FGC would be the right side. Oops. Okay, so that would be one example. Your other 2 options here are the front and the back, or the top and the bottom. Okay? Any questions on that? Okay, then we are going to talk about, gentlemen, stop talking. Something called a transversal. I think a lot of times people get this confused with transitive property. Just the word itself gets confused. So transversal, remember transversal is what we're talking about in this chapter. A transversal is just a line that intersects 2 or more coplanar lines. Okay, so an example of a transversal, let's say I have a line here and I have a line here. It's not a very straight line, is it? Okay, my transversal would be what cuts across both of those. So this red line is my transversal. It crosses 2 other lines that lie in the same plane. With this, you get several angles. Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. You're gonna work with these types of angles a ton in this chapter. What I want you to see today is just what they look like. Tomorrow and the days after, we'll do more working with them and how they relate to each other. But today, it's just where are they, what are they, Okay? So the first thing you need to note about this stuff is there are different parts to these angles. All of these ones, those are called interior angles. Okay, they're inside the two lines. So those are interior angles. But then there's also exterior angles. And those are the ones that lie outside of the two lines. So those will be exterior. Those ones and those ones. Okay, so outside the two lines, exterior, inside the two lines, interior. So we're gonna talk in this picture setup about 4 different types of angles. And I'm gonna see if you guys can come up with them just from the names of them, because the names pretty much tell you what they are. So the first one is called alternate, that's an A, interior angles. Okay, and alternate interior angles, I will often abbreviate as AIA. Okay, so if you see AIA, alternate interior angles. So think about what that's saying. Alternate meaning like opposite, and then interior. Anyone think they can give me a pair, so 2 angles, that would represent alternate interior angles? DJ.
Like 2 pairs and like 2, like 4.
Well, 2 that are alternate interiors, and then there is another 2 that are alternate
3,
interiors.
6, 4, and 5.
Right, so 3 and 6, right? Angle 3 with angle 6. They're on opposite sides of the transversal, but they're inside your other 2 lines, okay? So this would be like angle 3 and angle 6. Just remember alternate, think opposite. Okay? And then the other pair would be angle 4 with angle 5. Okay, so that's alternate interior angles. So then what is alternate exterior angles?
Oh,
7
1,
and
8, 7, 2.
7 and 2, and 1 and 8. And for alternate exterior angles, same idea. EA is fine for me. But that would be angle 1, and then on the opposite side is angle 8. Okay, so angle 1 and angle 8 are alternate exteriors, or angle 2 and angle 7 are alternate exteriors. Okay, probably the one that gets confused the most, I feel like, is the corresponding angles. So far we've had 2 pairs of each type, and that will be the case for any setup like this where it's 2 lines and 1 transversal. But with corresponding angles, there's 4 pairs, and here's how you have to think of it. If you think about corresponding angles, if we put them in corresponding locations, they will be corresponding angles. So you have a vertex down at the bottom and a vertex up at the top. If I'm looking at my bottom set of numbers, and I pick angle 7, for instance, okay? The location of angle 7 compared to the vertex is the bottom left, okay? What do you suppose would be a corresponding angle to that from that top set of numbers?
3.
Angle 3, right? Bottom left with bottom left. So we would say for corresponding, angle 3 and angle 7 are corresponding, okay? Give me another pair then.
4 and 8.
4 and 8.
6 and 2. 1 and 5.
6 and 2. And then angle 1 and angle 5. Okay, so they're in a corresponding location. Top left with top left, bottom right with bottom right. That type of thing. Questions on that? All right, then the last one, technically you could say there's 2 more, but the book doesn't cover same side exteriors, so we're just gonna talk same side interior angles. But if you see ever same side exteriors, it's the same idea, just on the exterior instead of the interior. So same side interior angles, and this one I will often do SSIA, same side interior angles, just to simplify things a bit. Can anyone tell me which angles you think would be same side interior? 4 and 6, right? So you're on the same side of the transversal, right? Here's my transversal. You're on the same side, but inside the two lines. So angle 4 and angle 6, or angle 3 and angle 5. Okay? So real quick, if you did same side exterior angles, that would be which two angles? If we said same side exterior. 1 and 7 or 2 and 8, okay? The book doesn't really cover those, but if you ever see it, that's what they are. Okay? Good on those? Okay, so here's what I'm gonna do. I'm gonna give you a picture, and you can tell me, actually I'm gonna give you two things. Yep, we're gonna go through all that stuff in 2 examples. So, example 1, actually maybe 3. Let's say we have this picture. So it's a rectangular prism, bless you. And in this picture, we have A, B, C, D, E, F, G, and H. Okay, so thinking through the different types of lines that we talked about, can you tell me lines that are parallel to AB, segment AB? We'll just do segments. Segments that are parallel to AB. Do you see any segments that are parallel to AB in this picture? Which ones?
Wait, where is B? Oh,
B is right here. Right, DC would be one. Okay, so if we're talking AB, DC would be parallel. What else? EF would be parallel. And HG would be parallel. Okay, so segments that are parallel. What about skew?
A, B, H, E.
Hold on. Skew to EF. Okay, so if I have segment EF, what is skew to that? Which one? CB would be one. Can someone else give me one?
Are you serious, John?
DH would be one.
No.
What else? There's 2 more. AD would be one. And CG would be one. Okay, so those are skew. Okay. How about, can you give me a pair of parallel planes?
How would I answer that, John? Just give me
So you have to name it with at least 3 letters. You could do 4. ABC what?
B, C, D, and H, G, F.
I'm listening, Micah.
Oh. A, B, C, D, and E, F, G, H.
Right. So you can look at this, right? A, B, C, D, that's a top plane. E, F, G, H is the bottom. Or you could have done left and right, or you could have done front and back. Okay? And you don't have to use 4 letters. You can use 3, but you need at least 3. Okay? Okay, last thing on this one before we move on to the next one. Oh, that's not what I want. Okay, can you tell me the segments parallel to plane BCGF? So where's BCGF?
It's on the bottom.
No,
Nope, it's on the right.
that's the right side.
So now it's gonna be.
So the segments that are parallel to that.
So the segment, so A,
Right.
a segment AB,
Yep.
and segment EH.
EH. Anything else?
AE.
Right. You gotta do the vertical too. So these two, but also AE and DH. Okay? Questions on that? Yeah. Okay, so I'm gonna draw you. I'm gonna draw you another picture here. Let's say. Actually, I take it back. We're gonna do this. There's one really similar to this in the homework, so I just want you to see the idea.
Check is like a dumb version of chess.
What are you even talking about right now?
She said she knows how to play chess.
Oh.
Like, chess is just for kids, bro.
Okay, well, talk about it later. If this is our setup, can you find in this picture, because the rule is you need at least 2 lines with a transversal, something that cuts through them, to find these different types of angles. Okay, so your 2 lines might be A and B with a transversal of E, or maybe you're going to look at A and B with a transversal of D, or maybe you're going to look at C and D with a transversal of A. Okay, you can use any combination of the lines with a transversal to come up with these angles. So if I wanted, for instance, a pair of corresponding angles in this picture. Okay, can you tell me any corresponding angles in here? So remember, corresponding means if you're looking at a vertex, so here's a vertex, here's a vertex, here's a vertex, here's a vertex. Do you have any that with 2 lines, the transversal puts them in the same location in relationship to your transversal? Was that going to be a hand up and then you changed your mind? No. Anyone see correspondings? John?
1 and 9. Yeah.
Nope.
No, 1 and
1 and 6.
1 and 6 would be corresponding. So angle 1
Oh, 2 as well.
and angle 6. Okay, now here's the deal with 1 and 9. The only reason 1 and 9 are not is because they don't share any transversal, right? It's 2 different lines and 2 different lines coming together. So 1 and 6 would be correspondings. Do you see any other correspondings? There's one more pair in here. Oh no, there's 2.
Yeah, you got.
1 and 2.
Oh my gosh.
Not 4 and 5.
4 and 9.
Oh, 4 and 9, yes. Okay. 7 and 8 aren't, because if you're using 8, right, here's the 2 lines. So that would be this line as my transversal. It would have to be this one or this one. But they're not sitting, like you're not using one transversal with 2 lines. There's 4 lines that you're using in that. You need to use 2 lines with just 1 transversal. The relationship there. Okay. Okay, so those would be corresponding. Can you tell me alternate interior angles? Do you see any alternate interiors here?
You got 4 and 2.
No, because again, that's 4 different lines. John?
5 and 3.
5 and 3. Okay, so angle 5 and angle 3. Hey, don't do that anymore.
Oh, this thing?
Mm-hmm.
I got you.
So 5 and 3. What else?
4 and 1.
4 and 1.
And then wait, I got 9 and 2.
Yes. Okay, 4 and 1, those would be, right, opposite sides of your transversal, but inside the two lines. And then 9 and 2 would also work. Okay, so that's alternate interiors. Do you see any alternate exterior angles? So opposite sides, but outside of the two lines that you're working with.
6 and 9.
6 and 9.
That would be 6 and 9. Okay, that's alternate exteriors. And then last one, same side interior angles.
7 and
5 and 3.
5 and 3 is alternate interiors. 7 and 3, you don't have, they all three intersect. You don't want your other ones to
1 and 6.
make, that just makes a triangle there, right? We want two lines with
same
one
side,
transversal.
Oh, 1 and 8.
8 and
That would be 1 and 8. Okay. Questions on that at all? All right, so those are the types of angles we're gonna be talking about. Tomorrow we'll get into more how they relate to each other and